Hello students, today we will discuss a new chapter, that is Unit 3, Electrochemistry. So in our today's class, we will discuss about electrochemical cell and then representation of electrochemical cell, and after that we will discuss standard hydrogen electrode, and then we will discuss electrochemical series. So at first, what is electrochemistry? So electrochemistry is that branch of chemistry which deals with study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to carry out non-spontaneous chemical transformations. That means electrochemistry is that branch of chemistry in which we will study how the chemical energy of a spontaneous chemical reaction is converted into electrical energy. Okay, again we will study how we will carry out a non-spontaneous chemical reaction, that means a chemical reaction which is not taking place by its own. Okay, so we will study how a non-spontaneous chemical reaction can be carried out with the help of electrical energy. Okay, so in this chapter we will deal with these types of topics. Okay, and the chapter is very important and we will learn some interesting fact about electrochemistry in this chapter. After that, let us discuss about electrochemical cell. So to convert one form of energy to another form, always a device is necessary. That means by using a device we can only convert one form of energy into another form. Okay, so electrochemical cell is that device which convert chemical energy of a redox reaction into electrical energy. So this one is an example of electrochemical cell, and this cell is known as Daniell cell. In this cell, two beakers are used. In one beaker, aqueous zinc sulfate solution is used. In another beaker, aqueous copper sulfate solution is used. Okay, and then zinc rod is dipped in zinc sulfate solution and copper rod is dipped in copper sulfate solution. So when the metal rods are dipped in their own solution, then due to separation of charges, one potential is developed. Okay, and that potential is known as electrode potential. Now this arrangement, that means zinc rod in zinc sulfate solution, after that copper rod in copper sulfate solution, these two arrangements are known as half cells, and they both combine to give the complete electrochemical cell. Now when these two metal rods are connected, they are also called metal electrodes. When these metal rods are connected by external wire, then the current will flow from high potential to low potential, and the electron will flow in opposite direction of current. Okay, that means I already told that when zinc rod is dipped in zinc sulfate solution, then due to separation of charge, one electrode potential is developed, or one potential is developed, which is known as electrode potential. In this case, the concentration of zinc sulfate is 1 molar. Okay, when the concentration of zinc sulfate is 1 molar, then the electrode potential developed is minus 0.76 volt, and electrode potential means reduction potential. We will discuss in later part of this class. Okay, and then in this case, when copper rod is dipped in copper sulfate solution, the electrode potential developed is 0.34 volt. Now when we will connect these two half cells or these two electrodes, then current will flow from copper to zinc and the electron will flow from zinc electrode to copper electrode. Okay, and when electron will flow or current will flow, we can use the electrical energy of this cell. Okay, now let us discuss how the electrons produced. When these two half cells are connected, then always remember that oxidation occurs at zinc electrode. That means zinc is converted into Zn2 positive ion, forming two free electrons, and those free electrons will move from zinc electrode to copper electrode through the external wire, and they will go to the copper electrode, and in the copper electrode the Cu2 positive ions from the solution combine with the two extra electrons to form Cu. Okay, that means in the zinc electrode Zn2 positive ions will come to the solution and the zinc rod will dissolve with time, and in the copper electrode or in the copper half cell, Cu2 positive ions from the solution will deposit it on the copper rod. Okay, that means the thickness of the copper rod will increase. Okay, now since zinc is changing to Zn2 positive, that means in this half cell or in this electrode oxidation is occurring, and then in another half cell Cu2 positive ion is converting into Cu. That means in this half cell reduction is occurring. Okay, so the half cell or the electrode in which oxidation occur behave as anode, and the half cell or the electrode in which reduction occur behave as cathode. So these are the important things you have to remember from electrochemical cell. Now if we consider the zinc electrode, then the Zn2 positive ions are coming to the solution from the Zn zinc rod. Okay, that means the solution is becoming positively charged, because initially the Zn2 positive ion and SO4 2 negative ions are equal, but now since Zn2 positive ions are increasing due to dissolve of the zinc rod, therefore the solution become positively charged. And after that, in the copper sulfate solution, initially the Cu2 positive ions and SO4 2 negative ions are equal, but now the Cu2 positive ions are depositing on the copper rod, therefore the numbers of positive ions are decreasing in this case, and hence the solution will become negatively charged. Therefore this inverted tube is used to connect the two half cells internally, and this tube is known as Sol bridge. Okay, and the function of Sol bridge is, first it completed the overall circuit, okay, and then it maintained the electrical neutrality within the half cells. That means in case of copper sulfate solution, the sulfate ions are increasing and the extra sulfate ions move through the Sol bridge to the zinc sulfate solution. That means the sulfate ions will move through the Sol bridge to the half cell containing zinc sulfate, and the Sol bridge will maintain overall concentration of sulfate ions equal in the two half cells. So these two are important functions of Solbris. So this one is electrochemical cell, and this cell is known as Daniell cell. So we have learned how electrochemical cell work. In this case, that means in case of in case of zinc, electrode reduction is in case of half cell containing zinc, oxidation is occurring, and in case of half cell containing copper, reduction is occurring. That means both oxidation and reductions are taking place simultaneously. Hence the chemical reaction is redox reaction, and with the help of this device we are converting the chemical energy of a redox reaction into electrical energy. Okay, and then let us discuss representation of electrochemical cell. So to represent electrochemical cell, simply two vertical lines are written at the middle, which represent the Solbris, and on right side of the Solbris cathode is written. Okay, and on left side of the Solbris anode is written. And in both sides of the Solbris, always remember that the metal ions are written, and the metal ions are separated by a vertical line from its metal. So this one is representation of electrochemical cell. So this simple formula is used when it is not possible to draw the diagram of electrochemical cell. Okay, and after that let us discuss oxidation potential. So we have seen that in case of zinc electrode, oxidation is occurring. Okay, so the tendency to lose electron in the above case, that means in case of the Daniell cell, is known as oxidation potential, and oxidation potential of a half cell is inversely proportional to the concentration of ions in the solution after the reduction potential. And we have seen that in case of copper electrode, reduction is occurring. That means the tendency to gain electrons in the above case is known as reduction potential, and according to IUPAC, the reduction potential is called as the electrode potential. That means the reduction potential is used as electrode potential or standard electrode potential. And always remember that the value of oxidation and reduction potentials for a same half cell is same, but their signs are opposite. If the reduction potential is positive, then the oxidation potential will be negative, and vice versa. Okay, and then let us discuss standard electrode potential. And in the electrochemical cell, we are considering 1 molar zinc sulfate solution and 1 molar copper sulfate solution. And when the temperature is standard, that means 298 Kelvin, and the pressure is 1 bar, then the electrode potential which is developed within the half cell is known as standard electrode potential. That means when all the species present in a half cell has unit concentration, that means the concentration is 1 under standard conditions, that means the pressure is 1 bar and the temperature is 298 Kelvin, then the potential developed is known as standard electrode potential. And to represent the standard electrode potential, the symbol naught is used on E, that means E naught. Okay, and then the difference between electrode potential of two half cells, cathode and anode. We have seen that in the zinc electrode or zinc half cell, the electrode potential developed is minus 0.76 volt, and in case of the copper electrode or copper half cell, the electrode or the standard electrode potential developed is 0.34 volt, and the difference between these two half cells, the difference between electrode potentials of two half cells, that means cathode and anode, is known as the cell potential. And cell potential, E naught cell is always equal to E naught cathode minus E naught anode under standard condition. So that means when we subtract the electrode potential of anode from the cathode, then the value obtained is known as the cell potential. And then let us discuss about standard hydrogen electrode. So it is not possible to determine the electrode potential of a half cell directly, from the complete cell. So to calculate the electrode potential or to determine the electrode potential or standard electrode potential of a half cell, one reference electrode is used, and that reference electrode is known as standard hydrogen electrode. And the standard hydrogen electrode consists of platinum wire carrying platinum foil coated with finely divided platinum black, and the wire is sealed into a glass tube and placed in a beaker containing 1 molar hydrochloric acid, and the hydrogen gas at 1 atm pressure is bubbled through the solution at 298 Kelvin, and the half cell is represented by this formula, and then this one is the standard hydrogen electrode. In this case, 1 molar hydrochloric acid is used as electrolyte. The wire is platinum wire coated with platinum black. Hydrogen gas is bubbled at 1 atm pressure. Sorry, it is not 1 atoms, it is 1 atm at 1 atm pressure, and the potential which is developed in the half cell at any temperature is 0 volt. Always remember that the electrode potential of standard hydrogen electrode is always 0 volt. So to calculate the standard electrode potentials of other electrodes, this half cell is used as reference electrode. And then let us discuss electrochemical series. So electrochemical series is that series which is obtained when the standard electrode potential of different half cells are arranged in decreasing order of their values. That means we have determined the standard electrode potential of different half cells using hydrogen electrode, and then the values which are obtained are arranged in decreasing orders, and the series obtained is known as electrochemical series. And this one is the electrochemical series. In this case, the values are decreasing from top to bottom, and the standard electrode potential of hydrogen is always 0. And always remember that one electrode which is present above other always behave as cathode. Suppose we are considering cadmium and nickel. So in between cadmium and nickel, the nickel will behave as cathode and the cadmium will behave as anode. And the metals or the electrodes which are present at the top of this series are very strong oxidizing agents, and the electrodes which are present at the bottom of this series are very strong reducing agents. So we have learned about electrochemical series. So in our today's class we have get an idea about electrochemistry, after that electrochemical cell, and then we have learned about representation of electrochemical cell, and then oxidation potential, reduction potential, after that standard electrode potential, and the EMF of a cell or the cell potential, and then the standard hydrogen electrode and its use to determine the standard electrode potential of other electrodes, and after that the electrochemical series and the use of electrochemical series. That's all for today's class. In our next class we will discuss Nernst equation, and thank you.